Gang, as we look at power in our Wi-Fi systems, it can be a little challenging because remember, the injected power into the system is going to be based on what? Milliwatts, right? That's what the power company gives us, watts and milliwatts. That's the energy. But as we look at our system, it's measured in decibels, right? So I have a certain decibel power that's coming into my access, that the access point is going to be able to release. The antenna is going to affect it in decibels. There could be free path loss over time measured in decibels. There's going to be absorption rates measured in decibels. So we've got to have a conversion that we can use to go back and forth between our decibels and our milliwatts. And the reality is that there's a formula that you use to convert, and it's real easy. The power in decibels is equal to 10 times the base 10 logarithm of the power in milliwatts divided by 1 milliwatt. Who has time for this? Especially if they're taking an exam. Nobody. And in the real world, you may well just go online and grab a calculator or use a converter as necessary. But if you're taking the exam and you want to be able to successfully do this, or you need to rough out the differences between milliwatts and decibels in your system, you can do so relatively easily because of the fact that there's some nice logarithmic breakpoints that give us relatively even numbers. And multiples of those powers gives us also even numbers. Here's what we mean. First, I want to focus our attention here on the baseline. Remember, we're using a reference point of 0 decibels, that's our reference baseline, is equal to 1 milliwatt. If you double the milliwatts, you take us to 2 milliwatts, that logarithmically takes us to 3 decibels. If you do 10 milliwatts, we found that that point took us to 10 decibels in power. Now, here's where the rule comes in. Multiples of these two increments give us additives of these increments. All right, so we add 3 decibels every time we double our power. We subtract 3 decibels every time we have our power. We add 10 decibels every time the power multiplies by 10. We subtract 10 decibels every time the power is divided by 10. Okay, so how does this actually play out? Good question. So let's say, again, we've got that reference point in decibels relative to milliwatts in power, right? We know that's our baseline. As we multiply by 2, that's going to take us and give us 3 milliwatts. As we multiply that by 2 again, that takes us to 4 milliwatts. Well, that means we're going to add another 3, and that takes us to 6 decibels. If we double again, right, times 2 again, that's 8 milliwatts. That's going to be giving us an add 3 more decibels, so that takes us to 9. Times that by 2 again, we're up to 16 milliwatts. That's going to be add 3, 12 decibels of strength, right? That's the logarithmic scale that we were looking at. That shape that we looked at like that is based upon this increment. And we could go back and say, well, what about the 10? Okay, so 10, as we look at that, to milliwatts, we got our 0 to 1, multiply by 10, we get 10, and we add 10 on this side. So we're going to add 10 every time we multiply by 10 over here. So multiply by 10 again over milliwatts, what do you get? 100 milliwatts. Add 10 in the decibel side, that means it's 20 decibels. When we get to 1,000 milliwatts, remember that's a watt, that's going to be equal to add 10 again, that's going to be 30 decibels, right? So every time you multiply by 10, you're going to add 10 on the other side. And you can mix and match these rules together as well, right? So let's say we're at this point. We first multiplied by 10. That took us to 10 decibels. Then we double that. So now we're at 20 milliwatts. What happens when you double your milliwatts? You add 3 to the decibels. So that takes us to 13 decibels is equal to 20 milliwatts. This is the basic way to quickly convert from our decibels to milliwatts or vice versa.